I make my access through the lingual of the tooth slightly above the cingulum. I am attempting to create a more or less triangular opening that includes the removal of the pulp tissue from the pulp horns that are situated most coronally. Proper initial access includes straight line access. If when placing the reamer it has to bend significantly to the buccal or lingual to enter into the canal pathway apically, more dentin should be removed in whatever direction the instrument bent to gain access. In this way you are increasing the straight line access for the instrument to negotiate to the apex. The next step is to take the largest reamer that will negotiate to the apex without excessive resistance to determine the canal length. In this case, we see the canal length to the incisal edge, our reference point, is 25 millimeters. The same reamer that was used to establish length is now placed in the oscillating handpiece that produces a 30-degree arc of motion at 3,000 to 4,000 cycles per minute. The reamer is vigorously applied against all the walls of the canal. Note that after shaping the canal with the 08-tipped O2 tapered stainless steel safe-sider, we skip sizes to the 15 safe-sider employed in the 30-degree oscillating handpiece, and again work all the walls vigorously in what we describe as internal routing. Following instrumentation with the 15 safe-sider, we again jump to the 25 safe-sider. This is often the case in teeth with fairly wide canals. Note that when the canals are wide, most often in the buccolingual dimension, we can place a small bend at the tip of the instrument to increase the instrument's ability to remove the pulp tissue from undercuts without having to remove extra dentin. Because the canals are so wide buccolingually, I was able to jump from the 25 to the 35 safe-sider. By placing a bend on the 35 safe-sider, I was better able to remove the tissue from the length of the canal even where undercuts exist. Stainless steel, even in thin dimensions, has enough body to not only remove the pulp tissue, but a small amount of dentin from all the canal walls the instrument comes in contact with. In this particular situation, the canal was so wide that I tapered the coronal 1/3 of the canal with a thin piezo reamer to remove some coronal pulp tissue trapped in undercuts. Final instrumentation is done with a pre-bent 40 safe-sider, once again vigorously working all the canal walls. With the bulk of the pulp tissue removed and the canal fully shaped, I use my final instrument, the safe-sider 40, manually to make sure I have apical patency. With patency established, I then dried the canal walls with paper points. Please note the establishment of straight line access and instrumentation. I then fit a medium gutta percha point that was cut back to the point it was at the correct length with tug back. Obturation of the canal consists of laying out an adequate portion of easy fill epoxy resin cement to fully coat the applicator and the pre-fitted point. Here you see me peaking up the cement so it is easier to coat the applicator and the medium gutta percha point. Note that I coat the applicator used at a length 3 millimeters short of the apex by coming into the cement horizontally and then pulling out of the cement at approximately 45 degrees. I then coat the canal 3 millimeters short of the apex using an up and down stroke, depositing the cement against the lateral walls. The applicator is designed as a bidirectional spiral, giving it the ability to drive the cement laterally as it moves up and down within the canal. After coating the canal with cement, I then liberally coat the pre-fitted medium gutta percha point and introduce it into the canal. I sear off the gutta percha and cleanse the area of excess cement. I use a heated plugger to adapt the coronal gutta percha to the canal walls. Throughout the length of the canal, a three-dimensional fill is attained by a combination of the gutta percha point and the epoxy resin cement that fills in all the voids between the gutta-percha point and the canal walls. The cement is dimensionally stable and bonds both chemically and physically to both the gutta-percha and the canal walls. The incisal opening is neatened with the use of a 4-round burr, the same burr used to create the initial access. We can examine the obturation because of the transparent walls of the model tooth. We took final x-rays in both the mesiodistal and buccolingual plane to access the effectiveness of the seal. The instrumentation process took no more than 15 minutes and used a total of 5 instruments. Frankly, the canal was so wide on this tooth that the initial instrument probably could have been a 20 that would have used only 3 instruments to shape this canal. You will find that depending upon the initial width, length, and curvature of the canals, the number of instruments you need will vary from as little as 3 to no more than 6, and those cases where 6 are necessary represents cases where the canals are long, curved, and narrow.